Good morning, ladies and gentlemen. Today we're starting our unit on circle and spherical geometry. And in the end, we want to start asking questions like, what is the shortest distance by plane from Moscow to Melbourne? Or, what time is it in Melbourne if it's currently 7 AM in Prague? And to do this, we have to use a fair amount of base knowledge with circles, and this video is going through some fundamental circle work, if you like. Alright, first of all, vocab. Very simply, radius from the middle to the outside, diameter all the way across. When we cut a circle up, we cut it into a major arc and a minor arc. Radius sector is this area here, and that there is the arc length. Alright. Now, right angles appear within circles sometimes, and they're extremely useful. If you have a line that's cutting a circle, it's called a chord. If a line cuts a circle, like this chord here, PQ, and we draw a line from the center to the midpoint of the chord, it creates a very important right angle, and it creates an isosceles triangle using the radiuses here. You may well have seen that before. Similarly, if you have a tangent is a line that just touches a circle. When a radius line meets a tangent, we create a right angle there. Right. Not hugely vital, but good to know for using with Pythagoras problems, and later on within a sphere they turn up as well. Alright, length of an arc. Here we're asked to calculate the length of the arc from A to B through C. Now you might recall that the circumference of a circle is 2 pi r. Well, the length of an arc is just the same. We call it S for some reason, but it's theta on 360 times 2 pi r. If for some reason your theta was 360, you would get the entire way around a circle. 350, most of the way around a circle, etc. I prefer this version of the formula. You may also see it written like that, which is the abbreviated version, or the simplified down version. Alright, an example. Let's say we're asked to find from J to H along the minor arc. That distance there would be given as S equals theta on 360 times 2 pi r, which would be 135 on 360 times 2 times pi times a radius of 10 centimeters, giving us an answer of 23.56 centimeters. Right. Area of a sector. Area of a sector comes from the previous area formula, where area, not coming along like here, area is equal to pi r squared. Then we multiply that by theta on 360 to get the resultant formula of this. Pi r squared theta on 360. Or you can leave it in the form on the right. That works just fine as well. So in our example above, what we have is area is equal to theta on 360, or 135 on 360, multiplied by pi, times the radius, which is 10 in our case, squared. And the answer is 117.81 centimeters squared. Alright, so that's the area of a sector. Now note, if we want to find the area of a segment is this highlighted yellow portion here. To find the area of a segment, we find the area of the sector, which looks like this, and subtract away the area of the triangle. Now, we know that area of a triangle can be found by a half AB sine C. Or, in this case, because that and that are both the radius, we can do a half r times r, which is r squared sine theta, which is the angle in between the two r's. So the formula for finding the area of a segment is that one there. The area of a sector minus the area of the triangle. So in the example here, different example, we have theta on 360, so 74 on 360 multiplied by pi times 8 squared minus a half times 8 squared sine 74, which comes out to be 10.57 meters squared. Right. Finally, last example, worded question. A person stands on ground level 60 meters from the nearest point of a cylindrical tank of radius 20. Calculate, the circumference of the tank and the percentage of the circumference that's visible to the person. Now read that again carefully, and have a shot at it by yourself if you wanted to. Good idea. Here's the person, and they stand on ground level 60 meters from the nearest point of a cylindrical tank. So this is looking above. Here is the tank, and its radius is 20. Easy enough. And the person is 60 meters from it. Alright. Firstly, they want us to find the circumference of the tank. Well, that's easy. We know that circumference is 2 pi r, which in our case is 2 pi times 20, radius is 20, which we can write as 40 pi, or abbreviate that to its decimal, which is 40 pi, 125.66 meters. Alright, now the second part is the tricky part. The second part asks the percentage of the circumference that is visible to the person. So you're looking at it, you think, well, the person can see half the tank. But that's not actually the case. And you can test this if you stand in front of a big tank or look really, really closely at your glue stick. You realize that you can't actually see the full half of it. You get cut off. Now, admittedly, I haven't drawn a very good circle there, but you can almost see from what I have done that this person is able to see this portion of the tank, but not this portion here. And the green is ever so slightly larger. Alright, so, excuse me. So, how do we work out how much of the circle we can see? Well, that's an interesting question. We would really love a right angle here because we need to find an angle somewhere. Because an angle or percentage, we can find this yellow percentage as a percentage of the whole circle if we can know what angle is between here and here. So to find the angle between there and there, what I would do is I would say, well, this here is 20, and we're making a right angle here. Remember, anytime a center line joins a tangent, we make a right angle. So what we've really got is a length here of 80, a length here of 20, and we want to find this angle here, theta. That angle is going to be that theta in there. And we have a right angle. So this, because we have a right angle, SOHCAHTOA, adjacent hypotenuse, cos theta equals 20 over 80. Theta equals inverse cos of 20 on 80. Theta is equal to 75.52 degrees. That means that the person can see double this, because theta is on the other side as well, which is 151.045 degrees. So as a percentage, that'll be the questions we'll be doing. As a percentage, this is 151.045 out of a possible 360 degrees. Multiplying it by 100 to get it into a percent, we would have 41.96%. You can see 41.96% of that circumference. Alright, so I realize that last one took a while, but they're not going to ask you, to be honest, examples like this in an exam. That's too easy. They can ask you to apply it in this type of question. Alright, thank you very much. Enjoy the next video.